Okay, for this video, we're going to go over resonance structures. And to do those, we have to talk about something called formal charge. But to start with, I want to review our Lewis structure rules to get them in an organized fashion. I know in my last video, I sort of went over them and did them in practice. But this is an order you can go with. So, 1. Some valence electrons. You have to do this first. This means you add together how many you have for your molecule and use that to figure out what should be there. So I'm going to take, so we do that. We add all those up. So the second rule we had was that we have to choose a middle atom. So choose central atom. And unless you're told otherwise, it should be M, assume the least electronegative atom. And I like to use En for electronegative so it's faster to write. So assume the least electronegative atom is in the center. Sometimes this won't be the case, but if it is, I will tell you in the problem. And as a note, hydrogen won't be in the middle. This is because hydrogen only needs 2 electrons. So it's not going to be bonded to more than one thing. Now, if you only have 2 atoms, you don't have to worry about this middle thing. 2 atoms can only be connected in one way. So the next thing you want to do, 3, is you want to complete the octets for your external atoms. But also, don't forget exceptions. So this mostly just means that your hydrogens are only going to get to 2. Don't try to take them to 8. Then, after you've done all of that, place your leftover electrons, and that's assuming you have any. If you have none, you can be done at step 3 potentially. You don't have to do step 4. So after step 3, if you have any leftover, place leftover electrons on the center atom. And then what you're going to do last is check octets or exceptions. For example, we talked in the last video, beryllium and boron only needed 4 and 6. Make double or triple bonds to fill octets if the central atom doesn't have enough. Okay? So if you go through these 5 steps when you're doing your problem, you should be okay. Now, this is to get one Lewis structure. The issue is some problems we work are going to have more than one possible Lewis structure, and we need to know which is the better structure, or are they all equal? So we're going to have to add one more concept here, something called formal charge. So now, I guess that's right, this is a video. Unlike in class, you could pause and write more stuff down if you weren't done. I'm still adjusting to that. So that's where I was going to stop for a minute and make sure everybody had it written down, but there's nobody in here because it is my bedroom with a board in it. Now, let's consider this molecule, SO2. Sulfur is less electronegative. I'm going to put it in the middle, and then I'm going to put it on the outside, the oxygens. And I'm going to note that sulfur, there's one of them, it has 6. Oxygen, there are 2, they have 6. So we have 6 plus 12, we have 18 electrons. So that gets me through steps 1 and 2. So step 1, 18 electrons. Step 2, S goes in the middle. Step 3 is we're going to take our electrons and put them on the external atoms until the external atoms have complete octets. So we'll go 2, 4, 6, 8, 10, 12. Now, so we had 18 electrons. We used up 4 with the bonds. That got us to 14. And before you started drawing the dots, it would have been better to come up with 14. I forgot to do that. Sorry about that. So, I know there's 14 that I have available for dots. I just drew 12. This means I have 2 left over. So now, our step 4, put any leftover atoms on the center, electrons on the center atom. We have 2 electrons left. We put 2 dots here. Now we go to step 5. Step 5 is check the octets. That one's good. That one's good. Middle atom isn't. That middle sulfur needs 2 more electrons, so it needs to borrow. So one option is to borrow these and form that. The other option is to borrow these and form that. They won't both happen at the same time. You'd end up with 10 electrons in the middle. But this means we could have this structure, or we could have this structure. So the question is, which of these is a better structure, or are they the same? The way we're going to figure that out, so both of these are Lewis structures, and they're called resonance because there are multiple possible answers to the same one. So resonance is when we have multiple possible Lewis structures. And when we have multiple possible Lewis structures, they're all going to contribute to the overall molecule, where the better one is going to be the dominant structure, and then the others will contribute to some degree. And in some cases, they'll both be exactly equal, and then they'll have an equal amount of contribution. So in this case, we're going to use something called formal charge to help us figure out, is this structure better than this structure? Formal charge is a bookkeeping tool we use. So what we do, it's got an equation. We use number of starting valence, and I'll show you with this as an example. So if you're not sure what I mean by that, that's okay. Then the way I'm going to colloquially say it, I forgot my lone pairs. We're going to subtract the number of bonds, which is going to be, so you can also, number of bonds or number of lines, and we're doing this for each atom. And then we're going to subtract the number of lone pair electrons, so number of dots. The idea behind this is what we're doing is we're saying each lone pair belongs to the atom it's on, and each bond we're going to split in half. Since those represent 2 electrons, we're going to give 1 to sulfur, 1 to oxygen. So the number of lines represents how many sulfur gets. So for example, here we have 3 bonds. Those 3 bonds represent 6 electrons. But sulfur is only going to get custody of half of them for formal charges. So it's going to get 1, 2, 3. So each line represents 1 electron that will be as part of the formal charge. So what we do now is we calculate these values for every atom in our system. So I'm going to do it. All these calculations are going to be for this SO2 right here at the top. So first we have the formal charge of the oxygen on the left. And I say the oxygen on the left because these oxygens are different. So I can't just give them the same values. So the starting valence, oxygen started with 6. This oxygen has 2 lines and it has 4 dots. So its formal charge is 0. I will then write it as a tiny 0. Now, I'll do the formal charge of the sulfur. There's only one of those. So it started with 6. It has 3 lines and 2 valence. So it's going to get a +1. So tiny +1. Then we have the formal charge of the oxygen on the right. And that's going to be started with 6. It has one line, and then it has 6 dots. So it had 6 lone pair electrons, and it has 1 bond. So this is going to be a -1. So that gives us a formal charge of -1. You can then apply the same rules to this one down here, and when you do, you'll get a -1, a +1, and a 0. So now we need a way to pick which of these structures is better. So we have 3 rules that we're going to go through. Let me make sure. So first we're going to look at, are any structures all 0 for its formal charge? If so, that's the best structure and you're done. This will happen sometimes. The idea behind this is we want to have the electrons mostly equally distributed if possible. So at a formal charge of 0, everybody's in a good spot and they should be happy. So if we have any structures that are all 0, we're done. That's the right structure. Pick that one. Question 2. If they're not all 0, which structures have the lowest absolute value? So what this means is you want to look through and see how big or small these numbers are in terms of absolute value. So for example, in this structure, we have a +1 and a -1, and here we have a positive one and a negative one. So these have the same absolute value. They both have an absolute value of 2. Sometimes you end up with structures where you might have a +1 and a -1, but then another structure will have a +2 and a -2. We will prefer the ones with smaller absolute values. So if you're given 2 options, pick the one with the lowest absolute value. Then step 3 in our final thing, so assuming 2 is still tied, so we went through 1, they're not all 0. 2, they got the same absolute value. Are the more electronegative atoms negative and are the less electronegative atoms more positive? The idea behind this is an atom with high electronegativity really likes holding onto electrons in a bond. If something's going to be negative, it should be more electronegative, if possible for stability's sake. So here, in both cases, the same atom is negative. It's an oxygen. And the same atom is positive, sulfur. In some cases, you'll end up with where you might have an oxygen that's negative here, but you end up with a sulfur on the end here that's negative in the other structure. So choose the structure where the more electronegative atoms are the ones that are negative, and conversely, the ones that are less electronegative are more positive. Now, if you get through all 3, and all 3 answers are still everybody's tied, then it's equal. So we'll say all structures are equally valid, would be my answer to this one. So if you get to a point where you've done all of this and they're still all tied, that means they're all equally valid structures, and you say that both answers are equally good. Now, what this means conceptually is that a real sulfur dioxide bond is not sulfur double bonded to one oxygen and single bonded to another. It's like a combination of these two, where they both simultaneously exist. So it's really like sulfur acts like it has a 1.5 bond and a 1.5 bond to the other oxygen. So it acts like 2 1.5 bonds. And we can determine this through different techniques where we can actually measure bond length in molecules. So this is, up here we did Lewis structures and how we're going to write them. But know that conceptually, if they're all equal, that means your real answer is you mix those 2 answers together and you get an in-between. So this molecule behaves like it has 2 1.5 bonds. So in this case, they were all equal. If one of them was better, I would circle or square it or whatever my assignment asked me to do, and I would pick the one that was better at something as the ideal for that structure. So this is how you do a calculation of formal charge, and you have to be able to do that formal charge calculation to be able to then find a resonance structure. Depending on the text you're using, they may write the formal charge equation slightly differently, but it'll be the same idea. In some cases, they'll specifically have like a 1/2 with this, and they'll say the number of electrons that are bonded. It's the same idea. Each line represents 2 electrons, so if I count the number of lines, that's like taking half of them, since each line represents 2, not 1. So just to note that sometimes you'll see some different representations, but otherwise this should be fairly similar. So hopefully that helps out. And this will finish up the stuff we have to do with Lewis structures and with resonance.